All right, welcome back. We are Game 3001, that's Artificial Intelligence for Games, in the winter 2022 semester at George Brown, and it's week 4, part 2 of our broadcast. First part was our lecture, now we're in our lab, and for this recording and session, we're going to be doing lab 3, and we're really going to focus on implementing obstacle avoidance as much as possible for you. So to help you with your assignment 1. So we're going to give you most of what you need to get assignment 1 pretty good. It's not going to be perfect and it's not going to be everything. Some of it you have to do on your own, like we mentioned, but at least you'll have most of the pieces that you need to get things going pretty good after today. All right, again, we're sitting at week 4, and earlier this week we talked about dynamic steering behaviors continued with combining them and the problems when we combine stuff. But this day today, we're talking about lab 3 and lab 3 goals. There's 2 goals. One, we'll begin obstacle avoidance, and we'll do that by implementing primitive raycasting. So that's what we're going to be doing. We're going to be using our standard obstacle game object. And if we look up online to start, we have a starter up online. First of all, this is being recorded and it's up on Blackboard. So here it is. There's the Blackboard link for this particular video. And under labs, you're going to see that lab 3 has a lab3.zip here. Please download the lab3.zip as a starter for today's lab. Okay, you cannot start it with what we did last week. We're going to start it with this one. We've added additional functionality here, modified some stuff, which I'll be talking about in a second. So please download this. And while you're doing that, let's talk about what we're going to do. So the first thing we're going to do is for setup, we're going to download lab3 zip and extract it into your Game 3001 labs folder. That containing folder we're going to put up on GitHub. And we're going to add a couple of audio lines into the start method in the play scene. So that's the first thing we're going to do. And let's get into that first to start going. So first, let's do the downloading stuff. So I've got lab3.zip right here. This is my start, just like your start. And I'm inside of the containing folder for section 400. That's you guys. And I'm going to just take this and go to the 7-zip and extract it to lab3. Hey, let's get rid of this now. We don't need that anymore. And we use, in this section, we use GitHub desktop GitHub or GitHub desktop. Let's kind of go with that one. And so we'll type in GitHub. There it is. And for GitHub desktop, what we want to do is target, again, section 401. I'm pretty sure that's you guys. Or are you guys 4? No, you guys are 400. You guys are section 400, this one. So now you can see that we've added lab 3. So we'll say added lab 3 project files. That's the first thing we're going to do, commit to main. And we're going to, after this, we're going to push it up on GitHub when it feels like committing, right? And we'll push it up on GitHub. And when we do, after it's done pushing, you can see up online, if I refresh, that you're going to have lab 3 in here. This is added lab 3 project files. Okay, there we go. 400, yep. And that's awesome. So that's our start. And what we want to do is go back in here and start it off. So let's go into lab 3 and kick it off. And let's talk about it a little bit. Let's talk about what we have, and let's talk about where we're going and what we're doing. Okay, these are all super important things as we move forward. So we started off. Here's where it looks like. Okay, and remember, we want to change this to, whenever we download something, change to x86. Okay, when ReSharper allows me to do it. And retarget your solution, please, because my code may not be like your code. So retarget your solution. Then let's run it and see what we have right now. So if we run it, I'll talk about this a little bit. And as soon as we run it, we're going to have our code compile and build. And we have our target. And we have our debug properties. Let's turn the acceleration rate way down. So something like 0.5 or 1. So we can see this thing march along slowly. And we're also going to turn the turn rate down a little bit. And we're going to turn on the debug, toggle debug on. We talked about this last time. And now let's toggle seek and see what happens. Take a look at this. When we move our ship around now, it changes the collider size. The collider changes size, right, according to where it's going. And this is what we were talking about last week. We're saying, you know what, rotation, and if we rotate the entire rect, that's going to be really bad, okay? And it's going to be really bad because rotating it, where we would have a different collision detection scheme, which would not be AABB, it would be OABB, object aligned bounding box, which is a totally different way of colliding and much more complex and more computationally expensive, which we don't need for our little program right now. So how do we accomplish this? How did I do it? Well, I created a couple of different functions. One of them was in our core util.h. So in our util.h, I added a new function that I called rotate point. I talked about this. How do I rotate one point, from, one part to the other? So I rotate a point at an angle in degrees around a pivot. That's what I'm doing. Okay, rotating a point, angle in degrees around a pivot. And this rotate point, what it does is it takes, a vec2 point, so x and y coordinates, right? I take this rotate point and I've created a brand new collision manager method for us to use, right? And that collision manager method is the rotate AABB. Let me show you what that looks like. Actually, let's go to the collision manager.h for a second. Rotate AABB, that's what it's called. So what this does is it takes in a game object, it takes in an angle, how much I want to rotate it. I create an array of 4 points, the top left, top right, and bottom left. So in a clockwise winding order, right? And what I do is I set up some parameters to start, some initialization, the position. I kind of create some aliases for everything: position, width, height, half height. And then I check to see if the object is centered or not. If it's centered, which most of them are, then what I'm going to do is I'm going to set up the array so that I calculate each corner of the bounding area. That's what I'm doing. By the way, notice up here when I say width and height, we use a new property that I've also created called bounds in the rigid body. Rigid body is another component that we have, and it includes now a bounds property. And this is kind of a long-term storage for our width and height. Later on, what we may do is move this around and call this size or something else. But for this week, we called it bounds. That makes sense for us. So that's great. So it takes the width and height of the object and uses that as the width and height. And what we do is we calculate each of the points: top left, bottom left. And once we do that, we loop through and we call the util rotate point method, which takes each of these points, uses the new angle, whatever the angle is, and the position of the ship, the middle part of the ship, wherever that position of the rotation is, or the object, and we use that as a pivot point. And that pivot point calculates the new point and stores it right back into the array. Then we initialize the extents, the top left and the bottom right. Top left is the top left part of the box, the bottom right part of the box. And from the top left and bottom right new points, we get the minimum and maximum values. And what we do is we set up the new width and new height. And we do that every single turn, every single frame. We set up the new top left and top right. And that's why when you run this thing, you see what we said, which is you see that that thing is changing shape. So this will change shape. Depending on where it's looking, it's going to keep changing shape. Okay, looks kind of neat. Questions around what we did. This is something that I'm giving you, right? So that way you can have better collision detection for you and for your games, not just for our assignment, but also for your game for game production too, if you need to. All right, great. So this is what we've done, and we have to add some preloading of sounds. That's what we want to do, right? So I want to put in the, let's go to the start method of the play scene, because that's what Alex has asked us to do. So scenes, here's our play scene, and we want to scope down to the play scene and go to the start method. There it is. And you can see what he wants to do is preload some sounds. Let's preload sounds. Preload is a way of us warming up our sounds before we can play them. And the way it works is this. We call the sound manager. We say, hey, sound manager, we want to go through the instance method to load the sound. We want to load it from our assets audio folder, and it's called the yay.og sound. We're going to call it yay whenever we call it up, and we're going to tell you that the type of sound is a sound effects. It's a sound effect. Okay, so an impulse sound or a sound effect. That's the preload. Let's do the same thing for the thunder sound, which is kind of like the boom sound that Alex talks about. So again, we're going to load the thunder sound, and we're going to call it thunder, right? Alex called it boom. It doesn't really matter. One or the other is fine. So let's take those two things. I'm going to copy these things for you. This is the first piece of code we're putting in, and I'll put this inside of the chat for you so you can do it too. Okay. Questions so far? Are you good? You should be good because, you know, we're going super slow, super duper slow here. All right, so let's try it and see if this works. So we'll run it, and then let's see if it actually does the colliding. Right, so again, if I was to turn it on, then we should see when we hit this thing, you should hear the boom sound. Or the yay sound. That's right. Yay. You should hear that now. So that is the yay sound. The yay sound means that everything is good, right? Because at the end of the day, what we want to do is when we're colliding with our target, we want to be happy. Trevor says, can't copy those. Why can't you copy it, Trevor? Not sure why. All right, so that is pretty good. We've done this part. That's the first part. And we're going along with Alex's requirements up here. So we've done these two things. Okay, next part, let's add an obstacle to the scene. Again, this is in a different order than I did earlier today, but that's okay. So where do we do that? We do that inside of the playscene.h. Here's the playscene.h. We include the obstacle. We already have an obstacle for you. So here's the obstacle.h, right? And the way to include it is to actually include it first as a game object. Let's do that. So it's going to be obstacle pointer. We're going to call it m_p, a member variable that's private, and it's a pointer called obstacle. Okay. And then now that we've used it, and by the way, if you want to know where I'm getting this, if you look inside of game object, there is obstacle.h and obstacle.cpp. We really don't have to change anything here. It's just a square or rectangular block. That's all it is for us, okay? And if I look up at the playscene.cpp now, how do I include it? Well, it's going to be right underneath the spaceship. So let's do that. So we'll say that, hey, obstacle, m_p, obstacle, right? That's going to equal to a new obstacle. And let's put it in place by using add child m_p obstacle. Yay. Awesome. And let's press play so we can see that obstacle in place. Okay, let's do that. It's that simple, right? So we'll see if it works. And there it is. It's pretty ugly and big and kind of towards the left side of the screen. Wouldn't it be nice if we can change the position of this obstacle around? It would be nice. Let's modify IamGUI in order for us to do so. So let's go back to all the way down to the bottom where we have our target properties. Let's copy this and paste it. And instead of target properties, we'll call this obstacle position or obstacle. How about we just call it obstacle? And instead of this will be obstacle properties, right? This will be target properties, right? So this is in the IamGUI function, like we saw before. And instead of getting the target, we'll use m_p obstacle to get a reference to the obstacle right there. And we'll put that there. And we'll change this to obstacle. We'll call this obstacle. And we'll also use, we don't care about the target. So we don't care about setting the spaceship's target. So we don't care about this piece. That's only for the spaceship. But we do care about the obstacle position being changed, right? Which is going to be the obstacle static array twice. And this is the code that we're going to use for adding the obstacle control to IMGUI. So copy this, and I'll put that in chat for you. You should be able to copy paste. All right, so that is the obstacle. Let's test this out and see if it works, right? So we should be able to move it around now with IMGUI controls. You can see now I have the obstacle position here. I can move it around, right? I can move this around, and I can move this around and this around. So this is kind of in preparation for what we need to do for the game. One thing would be nice is if I get a debug box that comes around the obstacle when I turn it on, and if I actually run this thing, that the ship actually collides with the obstacle. That would be really nice. All right, let's do that next. So let's go up to the top where we're doing the drawing. We have a draw rect, but instead of drawing the target, we have it commented out. Let's just use this thing, and we'll put it underneath the draw circle. I'm just moving it around, and just uncomment it. And instead of making a rectangle around the circle when we debug, let's make it around the obstacle. There's the obstacle. So obstacle position minus the obstacle width and the obstacle height. So we're going to get the top left corner of the screen, top of the lower, and then the width and the height of the obstacle. We want to put it in there. That's pretty awesome, right? And that's great. Draw rect, right? And that will draw the obstacle when we, or draw the rectangle around the obstacle when we want to. I'm not sure why you can't copy that, guys. You should be able to copy this, no problem. Not sure why you guys aren't doing that. Is it not allowing you to? It doesn't allow you to copy. Huh, isn't that interesting? I don't think there is a, I don't think there's an option for that in Zoom. I'm not cutting that off. Share screen, remove participant, no. Annotate, live script, reactions, hide annotations, hide floating meeting controls, optimize for video. No, there's nothing there that I can do to change that at all. Chat etiquette, I don't think so. In the chat, it says chat etiquette has been enabled, but I don't know what that means from my perspective. My controls do not include controls to remove chat etiquette. Don't know what that means. So maybe that is the way it is, so you can't copy paste, but that is not great that you guys can't do. At least you can see it though. So at least you can go to the chat and look up and see it, which is not optimal, but at least it tells you what it is. All right, so that's good. But what we want to do is the draw rect. So we want to do this, and let's see if we can draw the rectangle here and run it when we're in debug mode. So again, we're here, and if I toggle the debug mode on, now you'll see a green rectangle here and a red one there and a green one there. And then we toggle seek. You can see that that works, but there's no collision detection.
Yay.
Let's turn the collision detection on now, and that's happening down here. So what I want to do is let's get rid of squared radius check. We don't care about this. We do care about circle AABB check. That is the between the ship, the target and the ship. Let's do another collision detection where we're checking between the ship and the obstacle. So we can do that too. So M_P spaceship, and we can go with that and the M_P obstacle. Now we have to modify the AABB check right now because it doesn't detect what's happening. Let's go into AABB check, go to definition. And inside here, we have a little file right now that checks to see if we collide with the agent, but that's not what we want. We want to collide with the obstacle, right? And let's move this one away. And when we collide with the obstacle, we want to play the thunder sound, which is the boom sound that Alex talks about. Thunder. And that's that sound manager instance, play sound, and whatever the sound we want to play. Okay. And notice that the last part is, do we want to loop it or not, right? You know, and that's the second part. So loop is 0. If we put a loop is 1, it'll work. All right, so that is the sound manager. Let's try it out now and see if we can collide. And when we collide, we make a thunder sound. Let's try that out and just toggle. Right, makes that thunder sound.
Yang.
And then
Yang.
that's it.
Yang. Yang.
And if we do this,
Yang.
right, we can still make that thunder sound.
Yang. 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 Yang.
Okay, very interesting. This is a great place to put this up on GitHub because we now can collide with the obstacle. So we'll say added obstacle to the scene. Okay, so commit to main, and we can push. No, we don't have to do that. Rakim. All right, so that is the first part, and that covers what Alex asked us to do here. So we've covered the obstacle, the collision with the place scene, the obstacle object, the IM GUI, add a slider, right? As an example, to move the obstacle, we uncommented the ABB check, changed it to the sound to play the boom sound or thunder sound. We've done all of this. Now the hard part, this part. By the way, there's one part that's for you for this lab 3. Add a couple of whiskers on your own. For this, I'm going to start with the, so we've done all this, and it looks like we did a lot, but actually this is where all the work goes. So let's start off with the agent. So I'm going to start off with the agent itself. So remember that what I want to do here is talk about what we want to do. So this is potentially our ship. Here's our target. Here's our obstacle. And what I want to do with the ship is when I'm rotating it, so again, if I was to rotate the ship as an example and it detects the collision with the obstacle, what we want to do, and this is what for you to do, maybe you as a strategy, you want to slow it down. And as it slows down and it hits the other whisker as an example, then what you want to do, if it's hitting the left whisker, you want to turn it towards the right. So pivot it towards the right, move it a little bit forward, pivot it more towards the right, and then now you're going to see it's going to graze the obstacle. This is a danger with having a very short, set of whiskers. So what we can obviously do is make these whiskers longer. But the idea is when you change the direction of the obstacle, if I'm rotating as an example, and if I'm rotating and I hit this, what I want to do is turn away from this thing so that the ship skirts the obstacle in a few frames, and then turns back, and then kind of uses seek over time to get back to the target. That's the idea behind it, okay? But there's issues. There's issues with this. And one of the issues we talked about actually during lecture is the issue that what happens when you have this happen. You hit the corner. What do you do now? Even if you were to make these two whiskers here closer together, right? The problem is you might be able to turn, but the problem is you may turn to the wrong place, and if you don't slow things down, you're going to hit this thing anyway, right? So that's the thing. So a good thing is instead of being short-sighted, what we want is to be able to see farther. That's one thing we want to do. That's what we're going to accomplish. So 300 pixels instead of something like 150 pixels here. We want to make these ones maybe 75% the length of the front to give the front early warning as to what's happening, okay? Again, early warning is going to be for something you're going to do in your assignment. We're just going to detect that there's a collision, and I'm going to show you how this whole whisker thing works, or raycasting, how this works for simple raycasting. Let's try this out now. So in order for me to implement whiskers, we're going to use the agent superclass. So where is the agent superclass? We talked about this. The agent superclass is sitting in the core folder or filter. And one thing to note is the agent superclass is the superclass for the spaceship, okay? I want to add additional functionality here in the agent superclass because it makes sense to do so. So what I want to do is do a couple things. And Alex and I worked on this week to make it easier for you guys to understand. So here's how it goes. I want to add some whiskers, right? And the way we're going to do it is we're going to have a GLM vec2 object. This is in the agent superclass. where we want to take care of the left line of sight end point. Okay, the left line of sight end point, if we go back to our drawing, and if I just reset it, so here is this. This is the left line of sight endpoint at the end of the whisker. We want the middle line of sight endpoint and the right line of sight endpoint. For you guys, your job is to make something that goes like this and something that goes like this. So other controls here on the left and right. What the additional endpoints will do, or the more whiskers you add in, much smoother it's going to be to skirt this thing, because the more of these whiskers are on the left, if all the whiskers on the left are hitting, you want to turn your ship more and more and more, keep adding turning until there's none of these whiskers on the left are hitting at all. All right, that's how you make it work. So the left endpoint is 1. Let's add in a couple more. I'm just going to copy paste here. So copy, paste. Instead of left, let's call this the middle line of sight endpoint, and then the right line of sight endpoint. Could I make this into a array? Yes, I could. We're not going to do that right now, just keep it descriptive. We're also going to add in a vec2, another vector, which is m_line color, and the line color is going to have, kind of be a 3-dimensional or a 1-dimensional array with 3 elements, and you will have to change this. You will need to change this to 5 to support your whiskers that you'll have to put together, okay? GLM, we're also going to have, a Boolean array, which is going to be called collision whiskers. And that array, again, you'll have to change this, change to 5. It keeps track of each whisker colliding or not. Okay, that's what it does. And then finally, we need a float, which is m_whisker angle. And the whisker angle float is going to be the angle of the left and right whiskers relative to the front, or the heading, if you will. Okay, so wherever the heading is looking, wherever the direction I'm looking in, right? The heading is an angle that the ship is looking in, then the whisker angle will be relative to that. So I'm going to offset the left endpoint and the right endpoint relative to the angle that you've set, okay? And we need to set some value for the whisker angle when we move on. In order for us to use this, I use getters and setters, and some questions have always been, why do you use this and stuff like this? But I think the real reason is I'm trying to adhere to object-oriented best practices and allow us to make our stuff testable, okay, and extendable. So again, if I say I want to add a new getter, again, remember, if you think about what getters are accessors, right? And setters are mutators. I did it wrong earlier today. It was the other way around. So getters are accessors, setters are mutators. We want to set a GLM vec2 object to be returned by my get left line of sight endpoint. We're going to need this because this is going to help me when I want to get information about the left endpoint. Okay, how about the middle endpoint and the right endpoint? So again, you can see that there is an opportunity here for refactoring. So middle endpoint and right endpoint. So what we could do here is make just an endpoint array, right? We can have multiple whiskers, a whisker array, right? And the whisker array could be something that we have instead of left, middle, right. We can have some enumerations, and it would make things beautiful. We also want to return a reference to our get collision whiskers array, right, which returns the entire array, as well as I want to return a GLM vec2, and I want to, a vec4, which is the get line color, and I want to have different line colors for each of the whiskers. I also want to get the whisker angle, right? Where it's also going to return it as const. Yay. So those are the getters. And they correspond to this stuff, right? Line color, the collision whiskers, which is the array, left line of sight endpoint, right line of sight endpoint, middle right line of sight endpoint, all those things. And that's what these getters are for. I'm going to copy these so you can see them in your chat. Maybe it's so that way if I move on, you've got them. I know you can't copy right now because of reasons, but at least it is good. Shouldn't m_line color at the bottom be a vec4? It should be absolutely a vec4. It should be a vec4, not a vec2 array. Thank you for that. Vec4 is RGBA, so red, green, blue, alpha, and that's what this is. Thank you for that. So that's good, and let's move into the next part. So we're going to go into the setters now. So we did the getters, we need the setters. So again, we're going to say avoid set left line of sight endpoint. Again, people don't like this, but it is what it is. It also allows us to have more control. Let's copy paste these ones. So again, we could make this into like one getter and one setter for these ones if we had an array of some kind or a vector. So again, middle line of sight endpoint, and we also want to call this the right line of sight endpoint. Nice, nice, nice. And then also the line color. We want to set the line color, so void set line color. We want to specify the line and the color that we want to specify, right? That's the color that we're going to set. We're also going to set the whisker angle. Set the whisker angle, which is for both whiskers, to a float angle. Okay. We also want a public function to update the whisker position. So a public function, here's public functions, and we can say void update whiskers, where we pass in a float angle, whatever that angle is going to be. So that is your setters. I'm going to copy this and the public functions. Copy this, and hopefully that is going to help you at least keep up with all that. So that is me adding in getters and setters and properties and setting up our agent.h so that it's a little bit more efficient than what we have so far. We're going to add functionality for left, middle, and right whiskers, the line colors for each of them, and if any of them collide. And plus, what is the angle for the left and right whiskers relative to the middle whisker? What is that angle? You typed update. Update whiskers. Yeah, that's right. Update whiskers. That's correct. So the public function is going to be called update whiskers, and that update whiskers is going to update the whisker angle. You know, that's correct. I wanted to do that. I mistyped update. Update. There we go. How's that? Mistyped update. Awesome. All right, and then what I want to do is go up to agent and click on this little option, which gives me generate definitions by declarations. There's other ways to do this with Visual Studio as well. I want to uncheck the draw, update, and clean methods. We're going to use the resharper generate code option. And then what I'm going to do is I'm going to generate all these functions here as an example by clicking finish. So it's going to generate all these functions in the agent.cpp. Thank you for those corrections, guys. All right, so that's great. So now that I've got this, we just have to return everything. So if I want to get left line of sight endpoint, I'm just going to return m_left line of sight endpoint, right? I want to return, this is where we need an array, or a vector m_middle line of sight endpoint. We're going to return m_right line of sight endpoint. And then finally, get collision whiskers, we're going to return the array. So we're going to return m_collision whiskers, right? And when it comes to the line of sight line color, we're going to return the m_line color of from an index perspective, the line color of the array, which is going to be the index, whatever that is going to be, right? And one thing is we can make this const. So we can say that is const. So we're not changing this. That's good. Type safe this way. The whisker angle is the same thing. We can say that we're going to return m_whisker angle, right? And that is all of our getters. Yep. Oh, wait. Again, I highly recommend something like ReSharper. It'll make your job a little easier, for sure. I'll also check YouTube to make sure that you're good to go. Chunk. That's weird. You shouldn't get a SFX error. Try to play a null chunk. That shouldn't be the way. How are we doing in terms of our cast? We're getting kind of poor performance on YouTube today, which kind of sucks, but it is what it is. Hopefully it won't crap out too much. Looks like my drop frames, we're dropping lots and lots of frames, but more than half of the frames are being dropped. It looks like we're getting really bad performance right now. It's not me, it's the internet. You don't need to pay for it, Thomas. You can get it from, JetBrains Education. Remember? Yep. You never have to pay for anything. So JetBrains Education, remember that if you go up here to JetBrains Education, there is an educational account you can sign up for free. We talked about this earlier this semester, where you can get this, and that is the thing you can do. There's can you click on a link? Is that possible, guys? I'm not sure if you can click on that link, but that JetBrains for Education link is the one that you need to sign up for JetBrains. Okay, good. So do that. Yeah, really bad performance right now for some reason. I'm not sure why. Right, so it looks like the internet is not great. At least not for me. All right, so awesome. This is pretty good. We've done some stuff here in here, right here. And hopefully you've gone and done all of these getters. Let's do the setters now. So for the setters, it's kind of the same thing. What we want to do is we want to set the left endpoint and middle point. So we're going to say something like m_left set endpoint is equal to point, right? And again, notice that this will be const. And the same thing goes for the middle endpoint, m_middle is equal to point. It'll ask us to make this const. Right, so const. And set right middle point, set right point, m_right endpoint, that's going to be equal to point. And again, look how similar these are. They're dying for an array or a vector at const, right? And set line color is the same, which is m_line color, which is index. The index we're going to use is equal to the color value, right? And we can put const on both of those. So const and const and const. I don't know why it jumped like that, but anyways. And finally, the set whisker angle will be the same thing. m_whisker angle is equal to angle. And then we're going to also do angle, which is update whiskers. Now this is where we're going to do a lot of our work. So let's talk about these getters and setters first. All right, so did you guys are you with me? Are all the getters and setters working for you? Yes or no? Check mark if they are, X if they're not. And let's take a look at that frame rate, which we're getting pretty low frame rate right now. Get it? I see Trevor is a check mark. How about everyone else? Did you guys get the getters and setters? Stanislav. Thank you, Stanislav. Okay, Ethan, that's great. Who else? And Erica. Okay, so again, I have some of you. I need more of you, maybe a couple more, please. I want at least half of you. Okay, just waiting around for a little bit longer just to make sure you guys are good, and then I got to move on, unfortunately. So hopefully you guys got these getters and setters. I'm going to move on, guys. I'm sorry, I got to do it. So getters and setters, again, all I'm doing is taking these getters and setters and implementing them in the agent.cpp. That's all we're doing. Getters again, sure, the getters are up here. Again, all it is for the getters is we're returning the field that you're, that you've got here for color, for left line of sight endpoint, middle line of sight endpoint, right line of sight endpoint, collision whiskers, the collision whiskers array, as well as the line color and the whisker angle. All right, so that's the first thing. I got to move on, guys. So what I'm going to do is I'm going to go to the agent now. And in the agent constructor, what I want to do is I want to set up some, I want to do some initialization. Let's initialize the whisker color for all the whiskers. Let's also initialize the whisker collisions, right? And we're also going to initialize the whisker angle. Those are the things we need to do. So what we can do is for the whisker color, we can say m underscore line color, right? We can start off with 0, right? And that's going to equal to a GLM vec4, right? Where we want to say that that color is green. Okay. And we can do the same thing for a bunch of them. So let's say left line color, middle line color, right line color, right? So middle line color, right line color, and they're all green, middle and right. So that's the line colors that they start off with. That's what the whiskers are going to look like, similar to what we showed here in the diagram where they're all green. Okay? And then what we want to do is we want to do the collisions. So we're going to say m underscore collision whiskers. We're going to start off, we're going to initialize all those to false. So the whole, I mean, we could do a loop here, but I'm just going to do them individually for now. Okay, because there's only 3 of them. Okay, 1, 2, 3. As well as let's set up our m underscore whisker angle to 45 to start off. Okay, so that's initialization. That's initialization. All right, and let me copy that into your chat because that's going to go into your constructor function. Hopefully you'll be able to see that worst case in the chat, even if you can't copy paste, which really is terrible. That should give you a sense of what I'm doing. All right, so now that I've initialized everything, I need to start working on how the whisker, how everything is going to work. So let's go slow. I'm going to scroll down, and I'm going to go into that new function we made called update whiskers. And this is where all the fun happens. And I mean, like, this is where the actual whiskers rotate and all that kind of stuff, which is pretty cool. So that is what we want, right? And let's start off with the whisker angle. So the angle that we're going to get is the new whisker angle. So m underscore whisker angle, that's going to equal to the angle. When we do that, we're going to make this constant. The next thing that we're going to do is we're going to say, let's get the center or the middle whisker first. So middle whisker, let's set that up first, right? And it's going to be set middle line of sight endpoint is we're going to start off at the get transform dot position, so the center of the ship or agent, plus the current direction. All right, current direction is a vector 2, which is normalized. That's what this is, right? So vector 2, that's normalized. And then what we're going to do is we're going to multiply it by the get line of sight distance. The get line of sight distance is going to be here. And you know what? It'd be really nice if we set up what the line of sight distance is by default. So we're going to pause here, and I'm going to go up to the constructor, and let's set that up too. So we're going to say, let's initialize the line of sight distance. We're going to say that m underscore line of sight distance is going to equal to 300 pixels by default. So 300 pixels, right? That's what that is. Okay. All I'm doing is initializing this inside the constructor function. Right? So that is what I'm doing with the, let's just jump back down to the update function, update whiskers. So this is the first thing. So so what this does is it says, okay, what is my position? So I'm looking at this thing. This is the center position. And I'm casting the middle ray here. And I'm saying, okay, add in the current direction. So where am I facing, right? And then multiply the current direction by the line of sight distance, which is 300. So whatever this direction is, multiply by 300, take that new vector and add it on to the current position that I'm at. And that's the line that I'm going to draw. Okay. I want to do the same thing, but I want to do the same thing for the other one. So let's do the left one first. So let's do the left whisker. And the left whisker, I need some floating point numbers. So let's say float x is equal to a sine. Let's do a sine calculation where I say get the current heading. Current heading is an angle, right? Minus the m underscore whisker angle. So what is the current angle minus the whisker angle? As add 90 degrees as an offset, right? And we multiply that by our util deg to rad, which converts it to radians. So this is the x value of our new angle, right? Remember what we're doing is when we have this thing, we want to calculate this angle right here. So to draw it, let's draw it here for you guys. Let's use a red line. And so what I'm saying is there's an x and y component of this angle, right? So we're saying the x component is going to be this way. This is the x component. And then the y component is going to be this way, right? And that's going to provide the angle that you need for this whisker. That's what we're calculating here, right? So, so how much along the x-axis relative to the direction? If the direction is 0 or in front, then we're not going to really change the angle much, right? Whatever the whisker angle is. Whisker angle is going to be the offset between where, in the front and this angle right here. This is the whisker angle. Whisker angle is going to be, from here to here. Whisker angle, okay? And so that's the first thing. That's the x-axis. We want to do the same thing with the y-axis. So let's change the y-axis to that as well. And we'll say, instead of sine, we'll go cosine. And this is kind of inverted because typically we do x with cosine and y with sine, but here we're doing it the other way around. And we're going to get current heading minus the whisker angle plus 90 degrees again and multiplying it by deg to rad. We're then going to do that setting. So set left line of sight point. We're going to do the same thing that we had before. Let's just copy paste this one here, because now that we figured out what that angle is, instead of adding in a current direction, the current direction is going to be this angle we just calculated. We're going to say GLM vec2, where we add in x and negative y, and that will be basically calculating multiplied by the line of sight distance, which is currently 300, but we want to make them less long. So let's multiply that by something like 0.75 percent, so 75% of the length. Now, you know what? This hard-coded value, guess what? We could expose this thing, and we can use this thing, which is the whisker length. We could change the whisker length for the left whisker or the right whisker, and the line of sight distance can be something that we're using for, different reasons. So we can actually expose these things right to the IM GUI, and we can modify these things, but we're hard coding it right now as our first kick of the can. Let's do the same thing for the right whisker. So we'll copy this whole thing and go into the right whisker. So here's the right whisker. And the right whisker is, instead of recasting X and Y, we'll just use the same floating point numbers. And instead of adding 90, adding the angle, or subtracting the angle, we'll add the angle. That's what we're going to do here. That's the difference, right? This stays plus 90. This is the offset, right? We'll talk about the offset in a bit. Everything else is identical except for this. Oh, by the way, this has to change to left, and this has to change to right. Okay, and now you have your whiskers being drawn in the right orientation. Let me copy paste that for you and put it on the chat so you see it, just in case I leave this page as we continue. Okay, so that's the update whiskers function, and we would run this regularly in order for us to update where the whiskers are pointing. That's what we want to do. Okay, cool. And that, for the most part, is my agent class. I'm not changing anything else in the agent class other than that. So I've added some, properties, new properties for the whiskers. I've added some initialization for some of those properties, the new ones that I just made, right? And we've added getters and setters. We did those things. And finally, we have this update whiskers public function we can call, so we can update the angle of the whiskers as we're moving. Let's put this up on GitHub. So we've completed the changes to the agent.h and agent.cpp file now. Let's do that. So we'll say modified agent class to include whiskers. That's what we did. Commit to main, and we're going to push this up on GitHub. Now, if your code doesn't look like my code, remember, you can always go up online and look at GitHub. It's right here. So if you refresh and you go into lab 3, you can go into the source and you can look at agent.cpp, and all the changes I just made are right there for you to copy paste. Okay, so please go there and check as we're going. All right, so now that we've got the agent class, let's close it off. We don't need it anymore. We don't need the agent class anymore. We want to keep this as lean as possible. So let's close that off. We need to work within the play scene, and I need to work within the our game object, which is the ship. All right, I want to talk about the ship a little bit. So let's go to game object. Let's go to the spaceship.cpp. Let's look there, and we're going to make some modifications to this now. Okay, so let's take a look at spaceship.cpp. So we have in our start, we have a couple things, right? We have, we talked about the bounds that we added in. We saved the bounds. We did that. We set up the agent here. Okay, that's what we did. So that's what we did here in our spaceship. Okay, and we could set the line of sight distance if we want to, but we've already done that inside of the agent class. We don't have to do it here. Okay, so everything else is pretty much go. Seek is working okay, right? So seek, but look where you're going is kind of janky, right? So it kind of flops around a little bit, and I want to improve this. So let's get rid of the current stuff that we have and look where you're going. Let's just get rid of it. And let's make a better function. Let's reduce the sensitivity for our turn to 3. And then what we want to do is we want to say something that looks like this. Let's set the current heading of our agent to a util, and let's use a clamped function. We have a lerp unclamped, where I can start it off with the current heading, where we're looking right now, and where we want to look, that's the B. So where we are is A, where we want to be is B, right? And where we're going to, how often we're going to update this is T, right? And we're going to get the current heading, right? And we're going to add the target rotation. This is where we want to rotate to, right? And what we want to do is we want to move there along the turn rate, get turn rate, right? And we want to multiply by delta time, which is this value down here. And that is a lerp, a linear interpolating function that allows us to change our heading a little bit smoother. Okay, that's what we're going to modify in the look where you're going method. We also want to do a couple things, right? We want to update our whiskers. We'll do that here. So we'll say something like, let's update the whiskers angle, and we'll get the current whiskers, whatever that whisker angle is. And we'll do that every time we're looking where we're going. We'll update the whiskers. We'll change the angle of the, because we're changing our angle here. This is a great place to update whiskers inside of our spaceship. Okay. We also want to see how to turn if we hit something. So let's say if get collision whiskers, and if we look at the first whisker, which is the leftmost whisker, right? If the leftmost whisker is true, we're colliding, then I want to say that the target rotation is, let's add in the turn rate, right, multiplied by the turn sensitivity. Notice that the turn sensitivity is hard-coded. Again, we could probably expose this on in IMGUI to adjust the turn sensitivity as well. Let's take const away from here so that we can make that change possible. And this is the left, this is like if our left whisker is colliding. That's what that does. When it detects the left whisker colliding, then it changes the target rotation, which is the thing that we're calculating in our current heading. Cool, nice, nice. What about if it's the other whisker that's colliding? Get collision whiskers 2, right? So this is the right whisker. Guys, this is the place, right, where we're not telling you what's going to happen with the middle whisker. The middle whisker is your responsibility. We've gone from the left and the right, but we're not telling the program what to do with the middle whisker, right? And why, we can tell it to slow down, but that's part of your assignment, okay? We're going to say that the target rotation here is we're going to minus equals to the turn rate. We're going to move the other direction times the turn sensitivity, which is just an adjustment. So that is a number of degrees that we're going to match. Otherwise, the bigger this turn sensitivity, if you made it to 5, which was what we had, it would be even greater. And it says that there's a thing that says move the variable to the inner scope. Be careful about when it tells you this. All right, so that is really the look where you're going function, and that is the only thing we're changing really in the player, in the spaceship.cpp. So spaceship.cpp, done. Again, we can't test this yet. We're going to test these things, but this is the first part. This is the first part, is putting everything into place. So left whisker is colliding, then turn left, or then turn right. So we're going to turn right, turn towards the right. And if the right whisker is colliding, then we want to turn towards the left. Turn towards the left. What about if the middle whisker is colliding? You should do something else. Okay. And this is a smoothing function, right? That changes the heading of the spaceship slowly to align with the target, whatever that target is. Okay. This function here, it updates the angle of each of the whiskers right? On for every movement that we're doing. That's what update Whiskers is. Okay, so this is pretty cool. I'm liking this so far. Let's put this up on GitHub. So again, I'm going to go here, and I'm going to say, let's make sure everything's saved. We're going to say added. We'll say modified spaceship class to include Whisker input. So we're going to basically get Whisker input to align and move. That's what this does. So let's do that. We'll commit to main, and then we'll push this up. Okay. Awesome. That's great. Okay, well, what does this do? Does it affect our game? Let's test it, and hopefully it doesn't crash anything right now, because we made some changes to the agent. We've made some changes to the spaceship, but we haven't tested anything. And this might be a good place to test it out to make sure everything is okay. So let's relaunch. And when we kind of cast, if I just run it, you should see that it still works the exact same way.
Yay. Yay.
Okay, we don't see the whiskers yet because we haven't drawn them yet. Let's draw them now. So where do we draw the whiskers? Well, we draw them inside of the placing, right? So that's what we want. Okay, spaceship. Again, we can close the spaceship down because we don't care about this right now, right? So placeship, spaceship. The only thing we care about is the placing. Let's go into the placing.cpp and think about where to draw stuff. So right now we've drawn a circle around the target and a rectangle around the obstacle. We're going to draw stuff around the rectangle around the spaceship, but we want to draw something else. Let's get rid of this. I want to draw lines, right? That's what I want. And I want to do that, again, I'm in the draw function in the placing to do all this stuff. This is the right function to be in, right? So what we're going to do is we're going to draw a bunch of lines now. And we're going to do this. So this draws the spaceship. Draw the spaceship bounding box. That's what that does. We also draw the circle. So draw a circle around the target. This is the circle's bounding area. We're also going to draw a, the obstacle bounding box, right? That's what this does so far, right? And these are just little draw functions. We can actually say draw the target bounding circle. Okay, so what we want is we want to draw the lines. We want to draw the whiskers now, right? So let's draw whiskers so we can see them. We can visualize what they look like. Well, how does it look like? It looks like this. Util draw line, and we want to get lines from the middle of the spaceship, m_p spaceship dot get transform dot position. We want to start with that, and we want to use m_p spaceship, and let's draw the middle one first. That's get middle line of sight endpoint. That's the endpoint, right? Remember, because the line needs the start and the end, some kind of color. So that's going to be the color of the object, right? So our color of the object. So it's going to be m_p spaceship. And we want to get line color. And we're going to get line color 1 because it's the center. Let's just draw the center first and see what this looks like. And I'm just going to make it bigger for you guys to see it. So I'm just drawing a line. That's what it is. And this draw line function, we'll copy and paste this onto the chat so you can see it there. So I can move on. This draw line function, what it is it draws the line, for the spaceship, right? For the middle whisker. So if I run this thing now and I try it out, It's not going to do anything, but just the middle whisker will be drawn, right? So wherever it's looking, right, it'll keep on moving around with the whisker. That's what it'll do, right? So that's what it does. So that is what the line drawing does. We know that the whisker is working, right? Let's do the next one. Let's do the left one and the right one. So in other words, for us to do that, we need the left line of sight endpoint, right? And the line color for the 0th whisker. And we need to use the right endpoint with the 2nd line of sight color, right? And then we run it now. It's the exact same thing, but just changing those values. And we should see all three. It would be nice if we could modify the angle in IMGUI. So before we do collision detection, which is the next step to make all this work, let's change the angle in IMGUI. So I'm just going to scroll all the way down to the bottom of the GUI function, right? And just before the reset button, I'm going to add in another slider float. So I'm going to copy this last part and put it down in here. And we're going to call this the Whisker Angles. We'll call this Whisker Properties. Maybe there's going to be other Whisker Properties in the future. Who knows? So we'll call this the Whisker Angle. Okay, Whisker Angle is going to start off with M_P spaceship, and we're going to say get Whisker Angle. That's what it's going to be. That's the Whisker Angle. And that's what this will say. Instead of turn rate, we'll change this to Whisker Angle. And then Whisker Angle will go from here to here. This doesn't make any sense. 0 to 20. We'll start it off at something like 10. And it'll go up to, but not greater than 60, let's say. So 60 degrees. You can make this whatever you want to make it more realistic. And then your spaceship, instead of set turn rate, we want to update Whiskers. Update Whiskers. And by the way, you can also, if I set the Whisker angle, we can also do that here, right? But really, if we set the Whisker angle here, will that be good enough? Let's see if that works. If I said I want to update the whisker with the Whisker angle, set Whisker angle, if you look there, if I go to definition just for a second, yeah, it changes the angle, but nothing updates it like this. In fact, if anything, the set Whisker angle is like, there's no reason for us to do this. This is another function we can probably get rid of. Nothing's wrong with having a read-only function for some of these getters and setters. So read-only property would be only a getter but no setter, because really this doesn't do anything unless I call the update Whiskers function. So that's why it doesn't make any sense. So instead of setting Whisker angle, we're going to update Whiskers. And we're going to change it to the Whisker angle, which is this one. Okay, and that should update it in IMGUI. Let's try this out, and I'll put this in the chat so you can see what I'm adding in at the bottom. Okay, the Whisker Properties, this is inside the IMGUI function. Let's try it again and see if that works any better than what we had before. So again, here is the Whisker angle, and let's set the acceleration rate really low, right? Let's set the turn rate also very low so we can move very slowly. And we'll toggle debug on and toggle seek, and we can change the Whisker angle, right, to make it whatever we want here, okay? From here to here. Not bad?
Yay.
Right?
Yay.
And you can see the difference between one and the other.
Yay. 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 Yay.
Okay. No, you can't see the chat. No, you can't see the chat of the recording. The people who are watching the recording are going to have to watch the recording and slow things down and hopefully move things along as we move. All right, so that is pretty good. That's pretty good. Let's see how this is working now when it comes to debugging. So I want to make sure that we actually have collision detection. So where do we do that? So all of our collision detection, this is the crux of it. This is where we're going to stop, okay, when we do this part. So for the collision detection, what we want to do is go up to the update function. You see that we're already doing collision detection, right? So here's we're going to add in some of the ugly code, right? And I'm saying ugly code because there's some improvements we can make here. So there's going to be a block of code that I'm going to add in. I'm going to explain every part of it. But let's go to it. Let's take a look at the collision manager first. Let's go to definition for the collision manager. I'm going to open the collision manager up and talk about what we could do there. Because this is where it really belongs, some of this stuff, right? But again, we're coding to make it work. It doesn't have to be beautiful right now. So here, let's go to the collision manager.h, and you can see that we have a line check. Okay, what's the line check do? Go to definition. It takes a line start and a line end. It also takes a line to start and a line to end. So two lines, it compares the two, and it returns true or false. Are they colliding? Cool, I like that. What else do we have? We have a line rect check. Let's go there. So it takes a line start, a line end for line, right? And it also takes a rect start, that's the top left corner, a rect width, that's how wide it is and how high it is, how tall it is. So I need a rect start, rect width, and rect height. I have to calculate that, yeah? Well, there's another function down here that allows us to do the same things. Let's go back out. There's also a line AABB check. Let's go there. Go to definition. What's that one? That is, I get an object, right? In this case, the ship, okay? Specifically the ship, right? And that object, this is made for a ship, not any ship, the ship. Like in other words, if I go to game objects, it's specific for the ship. This was made, one time. I could totally modify this line AABB check so it can use any game object, not the ship's width and height and all that stuff, okay? And also notice that there is a line start and line end. Yes, but wouldn't it be nice if we had a agent, right? And now we know that agents, all of them have whiskers. Then we could calculate if one of the whiskers is colliding, and if it does, we can move on. We don't have that function, but I'm going to steal some stuff from here because it makes sense. We need to steal this part, the AABB part, that's found in your collision manager line AABB check, okay? So we have some chunky code, right? We're going to copy it, and we're going to put this part inside of the playscene.cpp. And I'm going to put that right underneath the rotate AABB part. And we're going to call this the obstacle information. Let's get some information about the obstacle, right? Because we need that. So obstacle information or aliases. That's what we have, right? And the reason why I'm calling them aliases because we can get this information manually, but why if I can just copy paste? So it is the obstacle information, and it's not just the obstacle information, but the obstacle AABB, dimension, right? Dimensions, right? I'll be okay, guys. The obstacle dimension information, just tired. And instead of object 2, which is what we have the obstacle, which is right here. We can use this and say, well, that's the obstacle get width, that's the obstacle get height, that's the obstacle transform position, and we take away half box width and half box height, and I don't have to do any of those things again. Yay! Once I've done this, I have all the information I need for each of my lines. Let's do the first one. So the next part is, let's check every whisker, to see if it is colliding with the obstacle. Okay, so how do we do that? Let's use the line rect check for that. Okay, we have the information. So we're going to say something like m_p, and we're going to say spaceship. We're going to get the collision whiskers, and we're looking at the left one first. Let's look at the left one first. The left one, we're going to say, is equal to, hey, collision manager, let's use a line rect check and pass in the information we need. First, we need the m_p spaceship dot get transform position. This is the line start. Okay, that's the position. And we're going to go to the next line here just to make it easy for you guys to see. m_p spaceship, and we're going to get the get left endpoint. That's the next piece. And we need to know the box start as well as the box width as well as the box height, because that's what we're looking at for the for these things here, the obstacle width, height, and half width, and all that stuff. Yeah, and that is the left whisker. Let's just copy paste now, and we'll do a line rect check for the middle whisker. So instead of the left endpoint, we'll use the middle endpoint. Again, this is dying. It's crying for some arrays or other kind of structures. Okay. Next, let's do 2, right? So get collision whiskers on the right side, and we're going to use the right line of sight endpoint. Right line of sight endpoint. Okay, so that's the 3 whiskers, and it's using the line rect check. And again, going back to the collision manager.h, if we look at the line rect check, which is this one, it returns a Boolean. Either I'm colliding or I'm not colliding. True or false. That's what it does. So this is great. This calculates and stores if the collision is happening for each of the whiskers. Okay, great. Now we need to color each of these to make sure that they show up in our user interface. So we're going to say, let's do a for I. And we're going to do a for I to the number of whiskers. We're going to say 3. Again, this is crying for some kind of enumeration or constant value, as opposed to what this is right here. We're actually hard coding it, right? And we're going to say m_p spaceship. We're going to set the line color of the current whisker, and we'll say, I'm just going to put it on the new line, m_p spaceship, and we'll say get collision whiskers, right? So the collision whisker that I want to, and if that collision whisker is true, if it's colliding, then change the line color to a vec4, which is red. Otherwise, change the collision color to back to green. Okay, let's go through this one a little bit so we understand what's happening. So I loop through each of the line colors related to the whiskers, and I say this. I'm using the ternary operator. This is the condition. I'm saying check to see if the collision whisker contact array, which is 0, 1, or 2, check each one, and for each one, if it's colliding, if it's true, if it's colliding, then this is the true part, right? Question mark says, if it's true, then assign this value to the line color. Assign this value, which is red. If it's not colliding, then assign anything after the colon, this color, which is green, assign that color to the line color. So in one line, really, this is one big line that is split over 2 lines, we can do the work of multiple lines, if, else, right, in one line, which is pretty cool. That is the code. Let's try it out and see if it works. And just going to expand this thing so you guys can see the whole code inside of the update function. Guys, this needs some kind of function, right? This function would be great inside of the collision manager. So I abstracted away from the placing. Doesn't make sense to be put here like this. Can it live here? Yes. Should it live here? No. It should not live here. It should be in the collision manager or somewhere else. Okay. But we're doing it here because we want to make this work. Okay. So let's try it out and see what happens. So here it is. And we'll turn the debug on. We will move, let's move our target away a little bit, like way over here. And let's move the obstacle up here. And let's slow things down, and we'll leave the angle as it is. And we'll start off with a whisker angle of this, and let's go and see what happens. So we detect, look, it's red, right? And boom, it collides, right? And we got some janky movement because it's colliding the whole way.
Yay.
Right? Let's reset it, and let's use the whiskers a little bit narrower. Well, now it kind of collides, it clips it,
Yay.
right? And that's better, but the problem with that is when it comes to this, it doesn't turn it enough away because look, it doesn't know you still didn't quite make it, right? So that's something we can do, but you can clearly see now that all the whiskers are turning red when they're colliding with the object, which is pretty cool. Okay. We can also make the angle a little bit wider, so just slightly wider, so not quite as narrow. Let's make it something like 30 degrees. And that might be a better configuration. Let's reset it again and try again and see what happens. And it's a little bit better, but still clips the side.
Yay.
And the reason why this is clipping the side again is because it's just not enough. So again, we tried something like a 26 degrees or 25 degrees. You know, and the reason why we need that extra bit of a few more whiskers, right, in the way that we've set it up is what the angle is for this. Let's also change the turn rate, and let's see what happens when I change the turn rate to something like 8 degrees. So a lot more. I can turn a lot more every time, right? And let's reset that and see what happens. So again, I'm here, but now I can turn much sharper. And like you say, it's just clipping the edge, right? Let's make it wider. Let's go back to that 30-degree mark, right? Wouldn't it be nice if we had control over how long the whiskers are? Wouldn't it be even nicer if we could slow the ship down when it collides? These are all things that can help us skirt the problem, this big block, right? So again, we're doing the same thing. Notice we're not even doing anything with that, but now it's skirting, and oh, look at that. Visually, we didn't collide, but logically we did because of the shape of the collider. So we want to be even further away. So this is pretty good numbers for us to avoid a visual collision, but not a logical one. Guys, this is where I'm leaving you. I'm leaving you with this part, right? So you have some work to do, right? And I'm going to put this up on GitHub now. So let's go into GitHub and we'll say added simple obstacle avoidance with Raycasting. So commit to main and push to origin. All right, let's take some questions because that's as far as I want to go today with you guys in terms of everything that we're doing so far today or for this week. What are your thoughts around this? Does it make sense? Is it understandable or is it not? And if it's not, it's okay, right? But at least we can figure out how you're feeling about this. Again, one thing we've done is we've handled this idea that we can move things around. So again, if I was to move this, you can see that as I'm moving, I'm detecting the collision, and then I'm getting closer, and you know what? I'm not doing anything with that middle ray, just getting closer. And when I come here, then I start to turn, right? And I keep moving in the same direction, slowly, 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 even if it's close. But what happens if I had another one? Then I know I would still be colliding and I would keep turning. But sometimes what happens is we have enough information where we can make it out, right? But we think we don't have to turn anymore, and we do, right? So that's something that we can do. We want to turn more. We want to slow down. The more we slow down, then the more our turn rate's going to take effect, right? So that's what we're going to do. Okay, so that's something that we want to accomplish. That's what we're working on right now. Let's take a look at Alex's requirements to see if we met them, right? So again, up on Blackboard, we see that we started debugging with Whiskers. We did that. We added methods for all line of sight in agent class. Will take a while. We took a while. Add a method for Whisker collision into placing. We did that. And there are two versions that Alex has added. One is my original version, which I'm just showing you now. And Alex has used the STL method that's built into STL, which is called intersect, rect, and line. Intersect, rect, and line. It is a little bit fatter than mine, but it accomplishes different things because the original only checks edges. And what STL does is it allows you, like if my whole whisker is inside of, for however it works, it probably will never happen. But if this whole whisker is inside here, there's no collision. If it's not touching the edges, right? Any of the edges, there's no collision with this thing, right? I mean, again, we probably won't ever get there, but you know, it's different than the STL intersect, rect, and line. It works differently. So that's why he did it that way. We did avoidance. We update the look where we're going to use the Whisker Collider Booleans. We did that in the Spaceship class. That's what we did, right? And now this is for you to do, these three things here, or these three lines. So for students to add, this is what you need to add. Add one or more left and right whiskers that are about 75 to 90 degrees out from the ship. Set appropriate changes to the target rotation so that the ship clears the box and doesn't graze it. And I highly recommend also that you modify the middle sensor, that middle whisker, so that you slow things down. It's up to you, but at least these ones are the requirements, and this is inside of your lab report that's up on Blackboard. Braden says you're getting special sound effects errors. Try to play a null chunk every time there's a collision. I saw that on the YouTube, but the only way that's going to happen is if you haven't loaded or preloaded the sounds properly. Okay, are you getting it for both? Or are you getting it for one? Remember, the way you check that is you go to, when we preload it inside of our start function. So in our start function, we preloaded the sound. So this is what the preload looks like. Make sure that the path is correct. Assets, audio, yay, and then the yay sound. Assets, audio, thunder, og, and then the thunder sound. This is how we would do that first. So you need to load them through the instance, going through the instance method and using the load method. So check this first, Braden, if this is correct, right? Otherwise, what you need to do is you need to call the play sound inside of the collision manager. That's when we're going to do it. But this is a key. You need to preload the sounds or it's never going to play. There you go. 3 dots instead of 2. It was just a pathing issue. All right. And that's it for me, guys. Any other questions before we go for the day? That covers your kind of initial kick at the can for object of or obstacle avoidance. By the way, the same thing can be done if we do it a little bit different with collision avoidance, which is if you're running in real time, you can kind of run the same thing where two autonomous agents try not to collide with each other. So if you're using this for your game production too, you can set this so it doesn't just detect obstacles, things to avoid, but also other enemies, right? So, okay, I don't want to collide with my friend. Let's move away. Let's move around them, right? Again, you might have some really weird, janky behavior unless you adjust things. Things to adjust, things that I would recommend adjusting or looking at, okay? Let me talk about some takeaways from this one. One of the takeaways, one of the look-ats for you guys is the player ship or the spaceship. Let's talk about this. The spaceship has a bunch of takeaways, all right? So here's some takeaways. One thing is we used a turn sensitivity of 3. So this kind of turns it in a certain way. We didn't add, like I said, some kind of middle whisker collision, right, that we can put in here. So that's something that you want to think about, right? And the turn rate multiplied by the turn sensitivity is just enough to change the target rotation. The target rotation is a number, a float that adds on to the current heading. That's what you want to do. So the current heading itself is a lerp, a linear interpolation with wherever we're going, wherever we're coming from to where we want to go. All right, that's what the target rotation is. Okay, and when we want to change the target rotation, we want to get the turn rate and multiply it by delta time, right? What if we didn't multiply this by delta time? Well, we wouldn't be able to do a linear interpolation. Delta time is the scalar, if you will, to slowly align us and move us around. That's what delta time does. And then we're also calling the update whiskers function here, right? Which again, some things that we don't have access to in IMGUI, we can expose more stuff. Like I said, one of the things we might be able to do is we can expose how long each whisker is. Okay. Okay, guys, that's it for me. Any questions before we depart for the day? Things to keep on the docket for things that are due, right? We talked about this earlier. So how are things due? Well, we know that Lab 3 individual is due Sunday at midnight. Its value is 4% of your final grade. That's this lab right here. Assignment 1, which is a group assignment, is still due tomorrow night at midnight. And that's valued at 10% of your final grade for both you and your partner. So this week is an important week because this week is potentially worth 14% of your final grade to get it done, right? Also, assignment 2 has been released. Start taking a look there. Things to note for your assignment 1. Go through it. Make sure that you handle it correctly. You have a lot of time to take a look at it. You've had a lot of time. And now you should have all the pieces, for the most part, to get your lab or your assignment 1 done with a fair degree of certainty, because you've got obstacle avoidance to some degree. It's not great. We've given you our code, right? But it's not fantastic. You've got seek. We've given you seek. We've given you look where you're going, right? You don't have arrival. You don't have that yet. You didn't do that with you. You don't have flee. You don't have that. So you have to do those two pieces. Plus, you need to make adjustments. Plus, you need to add sounds. Plus, you need to add all the other stuff that it's asking you to do. So you need to set up that stuff. So if you haven't had a chance to do it, guys, bear down tonight. Get it done tomorrow, and you should have your assignment 1 done and submitted. All right. Please make sure you don't go over time with this one. There's a lot to do, right? And we've given you most of the pieces. One question I got asked earlier today is, which in-class exercise, right? Which lab should I use, right, as an example to start? What lab is good to start? And I think that the latest lab, Lab 3, would be a good starting point for everything that you need, right? Because it has obstacle avoidance, some amount of it. You have a smoother rotation and look where you're going and a pretty good seek function. There's still a number of items to put into it in order for you to make this work. Any questions before we go for the day? Okay, guys, I'm going to stop recording on YouTube, and then we're going to go from there. All right. Okay, recording is done.